Hey everybody, so this is after school today. We tried to do a video this morning during third hour. I did record it and I had like one person or two people show up, I think. One person that stayed for the whole thing. But anyway, so I really did try to make the video today, but it transferred ownership. It got really weird. So I'm going to make the video again. So this is for you guys if you need it in order to do the practice problems from today. I'm going to show you what I did in class. And so hopefully you can get a few things done from that. Okay. So first of all, I'm going to go here and present my screen and I'll show you the notes that we did. Oh, and this is the sheet that you need. Let me find that really quick. Looks like this. Okay. That's the one. It's like, it says practice problems or something. It was on today's date, like Tuesday. And one of the first questions says, how do you know if a chemical reaction has taken place? So that's one of the things that you're going to have to answer. Well, if you look here at the notes, this is what we did in class. I ripped through these notes really fast today, and so that's probably what we'll do right now too. We talked about chemical reactions. We just went over the fact that a reaction is a process in which one or more substances are changed into different substances. We haven't done reactions at all yet this year. We've just been talking about bonding between atoms. So we're finally getting to the good stuff. This is the part of chemistry that everybody likes. So we have to know that you've got reactants or starting substances, and then once it goes through a reaction, you're going to have products or ending substances. Another thing that you need to remember, which I don't know if you can see that, is that mass must give way to the same mass. You should not lose any kind of mass during a reaction, okay? All right, so we know that a way that you can represent reactions is through a chemical equation. Chemical equation represents identities of reactants and products using symbols and formulas. Here's the first thing you're going to write down. And it says, how do you know on your paper, how do you know if a chemical reaction has taken place? Well, number one, energy gets evolved. So energy changes, in other words. So either energy will go into a system or energy will come out. Number two, if a gas is produced, that's another indication. If you have the formation of a precipitate, which is just a solid that gets produced as the result of a chemical reaction. So you could pour two liquids together, and if they produce like a solid substance that you could filter off, that's a chemical reaction. And number four, a color change. So one thing that we talked about today earlier in the classes was if you think like about a decomposing body, that is going through a lot of chemical reactions. There is energy changes that are going on. The body will begin to decrease in energy, will lose heat to its surroundings. Gas is produced. Gases get produced. There's a bloating that goes on as a body decays and decomposes. Formation of a precipitate, I think that this is part of like rigor mortis. You have buildup within the muscle cells of these certain chemicals, and then they'll cause the muscles to contract. I could be wrong about that one. I was stretching it there for precipitate, and then color change for sure. Another thing that they brought up earlier today was odor. Odor is a really good indication of a chemical change. Dead bodies definitely would have odor. So there you go. All right, characteristics of a chemical change. You've got to be able to identify all the facts in the experiment, all of the reactants, all of the products. When you're writing it in an equation, when you're representing it, you've got to have correct formulas for reactants and products. And so we said today, you've got to remember your diatomic molecules. In case you don't remember the diatomic molecules, we did discuss this earlier this year. I had the kids here on site write it down, but then we wrote it down again. I'm going to erase that. We'll come back to that. So we'll write down our diatomic molecules really quick. I'm going to save that formula for something else here in just a second. But here's your diatomic molecules, and this will go on that sheet right here. Okay, right there where it says the bank, you're going to write this right here. And there's a reason for this here in just a second, I'll tell you. But the diatomic molecules are It was the name of a band, right? Han and the Halogens. You have hydrogen, oxygen, and nitrogen. Hydrogen, oxygen, and nitrogen. These are the part that makes up Han, by the way. And this is just a simple way for us to remember it, Han and the halogens. But these 7 diatomic molecules, we're going to list the other 4 here in just a second. But these 7 diatomic molecules, this is the way that you would always represent this. If I ask you about hydrogen gas, you can't just write it as H with a little g. You would have to represent it with H2. Okay, that's how you would do the formula for hydrogen. If I ask you about oxygen, oxygen gas or oxygen liquid, you have to write it as O2. Okay, you can't just write it as O. Same thing for nitrogen, N2. And then, so Han and the halogens, this represents our diatomic molecules. Well, what are we talking about when you mention the halogens? The halogens are group 17 on the periodic table. So that's like fluorine, chlorine, bromine, and iodine. So we're going to write those down really quick. Fluorine, chlorine, bromine, and I'm going to make sure we can see this, iodine, or if you're British, iodine. Okay, and again, you want to say that these are diatomic, so you would have to represent each atom with a little subscript of 2. Okay, they don't exist alone in nature. They're not stable enough to, so they always have to have a buddy with them. Okay, so there you go. There's your 7 diatomic molecules. You'll need to know those because when you go to do formula writing, if I ask you about hydrogen or nitrogen or fluorine, you have to make sure you represent it as F2 or H2 or O2. Okay, so don't forget those little numbers. Back to the notes, really that was the main part of it that you needed to know. The other thing that we talked about today was the point of balancing, again, is just to satisfy the law of conservation of mass. You have to prove that you didn't lose anything going through the reaction. You don't lose any atoms, you don't pick up any new ones, you maintain consistency throughout the whole reaction, okay? So when you have this paper, so that's the top part. Then we started on this bottom half. So today in class, we went through problem number 1, and I gave them an example of how I wanted them to do it. And then in a couple of the classes, we were able to flip it over and do one example from the back. So that's what we're going to do right now. Okay, so on the bottom half of the sheet, it says, for the following problems, balance each. Then write the word equation and use the bank if you need to. Okay, so here's the equation that is on that paper. It's MgCl2 plus NH4NO3 yields MgNO32, and then plus NH4Cl. If you haven't done it yet, and if you want to, pause the video for just a second and see if you can balance the equation. Okay. All right. If you are balancing the equation based on making a list, which is what we practiced, and if you haven't watched that video yet, that was posted for Monday, and it's called Balancing Equations. So you could go back and look at how to make a list. For the sake of time, I'm not going to make a list. I'm just going to go through it and show you how I'd work it just without making a list, okay? So here we go. Again, you always start on the left and go right and work your way through it. Do one at a time. You look at magnesium and see how many there are. I have 1 magnesium, and I check it over here, 1 magnesium. So that one's good. I'm going to come back and look at my next thing. I have 2 chlorines here. I look over here at this side because I'm comparing it to this side. How many chlorines do I have right here? Just 1. So you have to balance it. The only way that you can balance any of these is by putting in coefficients. Coefficients are the whole numbers in front of a chemical formula that tell you how many groups of that thing that you need. So if I have 2 chlorine atoms over here, I need 2 chlorine atoms on this side, but the only way I can do that is by putting a 2 in front of the formula because that says I need 2 groups of this particular compound. So that would give me 2 chlorines. All right, so that's good. Magnesium is done, chlorine is done. So I'm going to keep moving across and I'll look at my nitrogens. In this formula right here, if you look at the whole formula, you have a nitrogen here and 1 there. So you have 2 nitrogens on the reactant side. How many do we have on the product side? Well, if you look in this compound, this 2 on the outside of the parenthesis would distribute all the way over here. So I have 2 nitrogens there. And then if you look here, this 2 distributes to everything behind it. So I have 2 nitrogens there. So on this side, I have 4. How many did I have over here? Just 2. So in order to make this match, I'm going to have to double the amount right here. Well, the only way I can do that is by putting a coefficient in front of the formula. So I have 2 sets of NH4NO3. Okay, so now my magnesiums are good. I have 2 chlorines and 2 chlorines. I have 4 N's, and over here I have 4 N's. Okay, now let's check our H's. How many H's do I have right here? And then you look at the whole thing, the only H's are right here, the only hydrogens. So you have 4 right there in the compound, but you multiply it by 2. So I have 8 hydrogens on this side. If you look over here, the only H's are right here, and I have 4 right there, but there's a 2 in front. So I'm going to multiply it. So I have 8 hydrogens. So the hydrogens are done. Oxygen, you look here, there's a 3 right there. And I have 2 right there. 2 times 3 would be 6 oxygens. And then over here, you look for your oxygens. There's only this right here. So 2 times 3 would be 6 oxygens. All right. So the ratios would be, I have 1 of these, 2 of these, 1 of these to 2 of these. Okay, that would be the correct balanced equation for this particular problem. Now, the other thing that they ask you to do on number 1 is to write the word equation. I told them earlier today, we really didn't go over how to name compounds in here because that's something that if you're interested in doing that, you need to take Chem 2 next year. And I will tell you this, if you're planning to go to college and do science in college, you will need to take Chem 2 because we skip over a lot of this stuff just for the sake of time in Chem 1. All right, so we will talk about how to name compounds next year in Chem 2 if you want to take that. So let's talk about how to do a word equation for this, okay? So that's why you have this little bank. It says you're going to have to refer to the bank. This is your word bank and your formula bank right there, okay? So you go down here and you basically just look to see MgCl2. You need to find words that match up with Mg and Cl, okay? One of the ones that is listed under ionic compounds, because that is an ionic compound, is magnesium chloride. So to write the word equation, I would say magnesium chloride, and then it says plus. So because these are reactants, you want to tell whoever's reading this that you understand that they're going to have to react together. So magnesium chloride reacts with, and then right here, NH4NO3, that's a weird one. These have polyatomic ions in there. If you didn't know what they were, you could always just Google it, like what is NH4NO3. It's actually listed right under here, underneath magnesium chloride. It's called ammonium nitrate, okay? So ammonium nitrate. So ammonium nitrate. So there's our reactants. Magnesium chloride reacts with ammonium nitrate. What does the arrow mean? What would we write for the arrow? Well, the arrow means to produce or to form or to yield. You could put any of those. It does not mean equals. This is not a math equation. It means to form or to produce. And then we'll go to the other side, okay? Again, you're just going to look on this, the bank right here, and you try to find something with magnesium in it. And once you have it, you can just mark it off the list because they're used once and they're done. So the next one up is magnesium nitrate. Magnesium nitrate. And because now we're on the product side, when products get produced in a chemical reaction, you could really just say you ended up with this and this, okay? So the plus sign here could just be and then right here it's NH4Cl, okay? So ammonium chloride is the last thing. Ammonium chloride. Okay, so there's our word equation. There's our sentence form. Magnesium chloride reacts with ammonium nitrate to form magnesium nitrate and ammonium chloride. You don't have to mention the coefficients. Okay, this is basically like writing a cookie recipe. Like if you were saying, if you wanted to bake cookies, you're going to need flour, sugar, eggs, and chocolate chips. And you would make chocolate chip cookies. If I wanted you to get very specific, then you could go back and say, here are the correct ratios. Here are the correct amounts. And then you could talk about, you'd have to have twice as much of this one as you do this one. This is a 1-to-2 ratio. So you could get more specific if you wanted to, but you don't have to when you're writing the word equations. All right. Okay. So there's that. That's what you're going to be doing for the front page. When you flip it over to the back page, they give you the word equation, and then they want you to create the formula equation and balance it. So basically, you're just working backwards. So let me go ahead and erase this. Take a look at number 4 if you haven't done it yet. Read over it, see if you can come up with some formula equations. I'm going to go ahead and write it up here too. Okay, when water is subjected to electricity, it breaks down to form hydrogen gas and oxygen gas. Okay, so we've got to take this and we're trying to put it into a formula equation. So what we talked about today is you need to look through this and then pick out important words and phrases so that you can make your formula equation. You're making your written chemical equation. So when water is subjected to electricity, it breaks down to form hydrogen gas and oxygen gas. Well, earlier today, they were like, oh, yeah, well, water. Water is going to be important, right? And somebody had said, it's subjected to electricity. Do we need to make a note of that? You don't really have to here. It's just extra words. I just put it in there just for your knowledge that that's how you would get water to break down, to break apart. Okay, so we don't necessarily have to do anything with this. It's just extra. But it breaks down. That's going to be important later this week. But here's our big ticket item, to form. So we know that's going to mean something, right? Okay, and then hydrogen gas and oxygen gas. Okay, so these right here are also going to be important words and phrases, okay? So can you pick out what's our starting substance? What are we starting with? Okay, and we're starting with water, H2O. You're starting with water. That's your reactant, okay? And it's subjected to electricity. It breaks down to form. What do you put in place of to form? What could we write? You could write an arrow. So to form. And then our two products then, hydrogen gas and oxygen gas. How should we write hydrogen? It's one of our diatomic molecules, right? So we're going to write hydrogen gas, H2, You could even put a little G beside it if you wanted to. Since I talked about water, you could put a little L beside that if you wanted to indicate that that's liquid water and not like steam or ice, like solid water. So this is hydrogen gas, and so plus oxygen gas. How do you write that? O2. Okay. So there's our formula equation. The last thing you're going to have to do with this is balance it. Okay, so you're going to have to balance this equation. So real quickly, let's just do it at a real fast balance here. We check H's. You have 2 here, I have 2 here. Perfect. I have 1 oxygen here, but over here I have 2. So you're going to have to fix it, right? The only way that I can do this is to add a coefficient in front of the whole formula. That would give me 2 oxygens, which is great. But now I need to go back and check my hydrogens because it's messed it up. 2 times 2 would be 4 hydrogens. How do you get this to be 4? Put a 2 right there. Okay. Anyways, that's what we worked on in class today. That's what you're going to be doing. I do want you to try all of these. Please make sure that you get them done. If you have questions, hit me up tomorrow during 7th hour, or email me and say that you need a meet, and we'll meet up 7th hour. We'll do a Google Meet. So but I'm going to wait for you guys to email. So I'm not just going to run a Google Meet. So let me know if you need help. Good luck.